I'm really pleased to be here tonight on behalf of Jillian and Fire Services and City of Peterborough and the consulting team as we work towards this really exciting fire station project. So I'm hoping that everyone can see my screen and that there's no issue there. Okay. So I will just move through this and acknowledge that we're meeting tonight for the Peterborough Environmental Advisory Committee, January 19th, 2022. So just a little bit about the project team. We wanted to give you a sense of the holistic approach that's being taken on this fire station. The team does include a full design contingent with architectural, mechanical, electrical, landscape, and civil, as well as cost consultants and sustainability consultants. All the team members have several fire hall and emergency services projects in their portfolio, as well as LEED certified buildings at various levels. So in summary, on the project team, this is an experienced and multidisciplinary team that's engaged and is determining the optimal set of solutions for this project, of course, with your assistance. So team members include, of course, Jillian as the project manager from the City of Peterborough, Bill Lett, Michael Gallant, myself, Eileen McKenzie, Harry Tang, and Amanda Motier from Lett Architects, Michael Pelton and Grant Peters from Fluent Group, and we have Grant joining us this evening. Dennis Codabelli from AMR Engineering, Jeff Greer from Durham Energy Specialists as our mechanical design consultant, Luigi Conforti also from Durham Energy Specialists as electrical, Aaron Hill with his team at Engage for civil design, Brian Basterfield with landscape design, and we have Ted Hyde from Marshall Murray as the cost consultant. So as a major contributor to this team, we've had the pleasure of working through this, this project and presenting the sustainable design workshops with the environmental advisory folks. And so our first session workshop was May 27th, at which we've gathered quite a substantial amount of information and direction from the group, and followed that with Sustainable Design Workshop 2, August 5th, and finally meeting tonight with the Peterborough Environmental Advisory Committee to review the status of the project. So thank you for having us. The scope of this project is an 11,000 square foot single story post-disaster timber framed building with glue-lam beams and cross-laminated timber for shear walls and the roof. We are building on a brownfield site, and this proposal impacts little or no existing trees and reuses much of the current grading from the existing building site. We will have a full solar photovoltaic array on the roof. Geothermal heating and potential rainwater harvesting will provide for the net zero energy certification to be achieved through this project, while material choice and carbon accounting will assist us to bringing the building in line with net zero carbon certification. So this is sited at 100 Marina Boulevard, where the current Northcrest Arena exists and is currently under demolition. So we wanted to illustrate here that the existing entry is being maintained in this location, but upgraded for the purposes of fire services. So the location is really prominent and important there. That the grading is largely being reused and just adjusted for the purposes of the fire department. The footprint of the project doesn't extend quite as far as the existing Northcrest Arena, and we can go into that a little bit further detail later, and that we are looking at preserving the tree line at the north of the property. We have the great fortune to salvage material from Northcrest Arena in the process of demolition, and so there are some timber joists that are being salvaged from the roof and some of the ceiling material that will be reused in the fire station proposal. This site plan demonstrates in context with the community just how extensive the site itself is and how little of the site we're hoping to develop. The developed area of the site really sits close to Marina Boulevard, and the placement of the building and the siting of the parking and so on really does consider its neighbors. We've been conscious of the location of Riverview Manor with the siting of the building and the proposed adjacent residential development to the southeast. The way that the building plan is developed is that we have the house portion of the fire station at the east side of the property, and this really acts as a buffer between the apparatus bays and the busier portion of the fire station and those residential neighbors. So it's a nice clustering of residential pieces, if you will. This also shows us that public access through both the north portion of the site is available to the park, as well as maintaining those wildlife corridors, which are important to this coming official plan. The civic building sits within civic functions like the open area as the park exists, and that also works towards the requirements of the official plan. So our site in closer detail, we have a number of features on the site that we wanted to draw attention to. First is the visitor parking location at the southeast corner of the building. We have the truck bays, as I indicated, that are off to the west side of the building. Staff parking sits at the rear of the building, and we're planning in future EV charging stations. There is a generator on site that's located at the rear of the building. The diesel fueling station is for the refueling of trucks. The fire station has developed, the fire department has developed training prop area that will allow them to continue training on the site. And we, of course, have snow storage areas that are held off the parking area. The bioretention area facilitates stormwater management on the site and ensures that our low impact developments are a critical part of this design. And then finally, we're maintaining the existing park as is that sits adjacent to the property itself. A few other key features to note: that the lighting on the site is all dark sky compliant without interfering onto adjacent properties. The orange location shows a rainwater harvesting tank underneath the parking itself. We have geothermal wells for the building heating and cooling located in the parking. Again, featuring the bioretention area for that on-site stormwater management. And on the roof, we will have a full photovoltaic array. With regard to landscape information, we are including 2 street trees to maintain the existing boulevard along Marina Boulevard. We'll have a garden area with signage at the front of the building to draw interest and to create additional habitat. There are 2 garden areas. Number 3 is at the visitor parking, and number 4 to the west of the apparatus bay apron, and both planted with native and drought tolerant plants. Again, highlighting the landscaped bioretention area and stormwater control at the northwest corner. And there's naturalized planting area along the fence line at the back. Again, night sky compliant light fixtures minimizing light pollution will be used on the site. The exterior of the building, we want to ensure that the landscape works with the building. So the landscaped areas really provide an opportunity for ensuring green space and lessening the heat island impact within the parking areas. We have, as I noted before, pulled the building back and the site development back from the current Northcrest Arena setting, which allows us regreening of the property and emphasizes the importance of minimizing the asphalt and hardscape spaces on the site. The canopies provide for coverage at the extensive glazing areas, and so ensure that we're not overheating the building. The glazing does, however, provide a lot of substantial natural lighting within the building and offsets the electrical lighting load required for daytime operation. There's a number of features in regard to the material applications as well. So we are considering the use of wood cladding at certain key elements of the building, and wood being a carbon sequestering material helps with the carbon accounting side of the net zero carbon application. The structure itself, as I mentioned in the introduction, is a timber framed structure, and so that also, as a wood element, is carbon sequestering. And then looking at locally or regionally sourced materials for the rest of the materials. And I will turn over to Grant Peters to look at the rest of the information in the proposal.
Thanks, Alan. Hi, everybody. I'm just struggling with some battery issues, so I may turn off the video at one point, but I am here. Hello. So I'll try and quickly walk you through the slides. I think more of the discussion will happen afterwards when we're talking about different approaches and strategies that we've got so far. So the short story is that our firm did a very comprehensive feasibility study for the project. This group was involved a couple times earlier last year, as Alan mentioned. That study is now complete, and the intent here is to provide you with the results of that study and talk about where the building's at. So one of the major pieces is the energy model, which also has to do with the carbon and emissions accounting piece. So this is just some background on the process. If you have questions about it, let me know, but I'm not going to go through that line by line, so we can move on. Sorry, Alan, do you mind? Next slide.
Sorry, you don't want the scenarios?
Oh, yeah, sorry that hadn't popped up for me yet. So yeah, sorry, thank you. So as part of the feasibility study, we looked at a number of different design scenarios as it related to energy performance. So they go A through F, and these are all improvements upon the building code requirements. And so, there's a number of parameters there, but basically looking at different mechanical systems, different insulation values for the walls, the roof, the windows, and different lighting, power density targets for the electrical design. And each of those build upon each other so that F is sort of the highest performing of the group. And that is, in fact, where we settled as a design team. So that includes ground source heat pump for heating and cooling energy, very high performance walls, roof and windows, very low lighting power densities. And so that combination of factors is sort of the baseline and where we stand at the moment. Next, please. So there's a couple graphs here. You don't have to worry about the metrics per se, but this is called energy use intensity, or EUI. And again, the baseline on the far left is code. And you can see a number of these scenarios drive down to where we ended up. And blue is electricity and orange is natural gas. And so you can see we ended up on an all-electric solution, which again is helpful for the zero carbon performance that the building is pursuing. Next, please. Cost intensity is not one that it is always reviewed in as much detail as energy intensity, but because the different utilities have different costs associated with their energy content, you can see here on a per square meter basis, we are still ending up with the least expensive option operationally, but it's not nearly the same reduction as when you're looking at the energy consumption metrics. And that's because the cost of electricity for the same unit of gas is much more expensive. And so the electrification piece, while a big benefit for the emissions calculations, is not as beneficial when it comes to the cost calculations. Next, please. So here's the big sort of reveal is the emissions piece. And so again, F being all electric, removing all that fossil fuel consumption from the building, especially when compared to an OBC or Ontario Building Code baseline building, where the majority of your loads for heating, hot water are all served by gas. That reduction is over 90% in an absolute sense. And so, again, the scenario we ended up with on F is the lowest cost operationally and also the lowest emissions-wise and the lowest from a consumption perspective. Next, please. This just shows you where that energy is going. So again, in scenario F, you can see the various loads. This is fairly typical for a fire hall project. What's different here is that the loads for heating and cooling are smaller than traditional equipment where you would have rooftop units or even maybe a boiler system providing the heating. So the energy use was reduced as much as possible from a mechanical electrical perspective. And this is sort of the ratios of where we end up. And you can see the big one there, lighting at 23.5%, space heating a little more than that at 28. But you may see heating, upwards of 40% in a typical commercial building. And so driving down those values was part of the design process. Next, please. Also, throughout the feasibility study, we talked about the orientation. This isn't obviously the site plan you saw earlier, but this is just to give you a sense of the exercise we went through in terms of siting the building and looking at its rotation, both relative to the street front, but also to south, so that the solar PV system or photovoltaics would have the maximum output possible. If you have an existing building you're putting the solar on, you're kind of stuck with the orientation of the building, but we had the opportunity here to actually tweak, by a few degrees the way the building was laid out on site, and that should improve the performance of the renewable energy systems. Next, please. Island spoke briefly about materials. We're looking, very closely at some of the key materials and how they relate to embodied emissions. And so this is a big movement in the construction industry. 5-10 years ago, this wasn't being talked about at all. And now it's become a much more prevalent discussion point, especially during design and in the architectural world. So the reuse of the materials from the arena, the move to mass timber, careful selection of the insulation products. These will all be driven by the carbon discussion, and a full life cycle assessment of the envelope and structure will be done as part of the zero carbon certification standard that the project is pursuing. And so there'll be a very transparent, document that outlines what the embodied energy is of the materials in the building, and that can be used by the city, by the public, by other practitioners in the industry to learn how those decisions are made and what impact they've had on the overall carbon impact. Next, please. Eileen talked about some of the site features. This is, again, just from strictly an environmental perspective, looking at the light pollution aspects, minimizing the water demand on the exterior. We've had quite an extensive discussion about rainwater harvesting, and we'd be very interested for the impact or for the feedback from this group on how that relates to your expectations of the building, or thoughts on how the city should proceed in that regard. And I can provide more detail if there's questions about it, but right now there is a 7,500 liter cistern that's proposed. It would collect water from the rooftop and be used to plumb back to the indoor plumbing fixtures, as well as potentially the truck wash stations within the apparatus phase, and also potentially the landscape hose bibs on the exterior of the building. So quite a few different water uses it could be used for. And that is obviously offsetting the potable water that the building requires. On the certification side, the building is currently registered with the Canada Green Building Council for the zero carbon standard. This is, obviously you need to have a very strong energy performance to get there. The building's also pursuing net zero energy from a performance perspective. This standard in particular with respect to carbon draws in on the materials aspect that we discussed, as well as the energy calculations. So right now, there's enough solar proposed on the roof to offset 100% of the energy used on an annual basis for the project based on the energy modeling. Next, please. Yeah, so these are the things I just discussed about that standard, and I'm happy to discuss any more details about that standard if there are any. Next, please. Oh, that does wrap it up. So that was fairly quick, but I guess in conclusion, the feasibility study landed on that scenario F. In addition to the solar on the rooftop aiming for net zero energy as well as net zero carbon, but with auxiliary environmental impacts on water consumption, indoor air quality, materials reuse, construction waste management, these sorts of things. So a lot of those less prevalent environmental features, a lot of people talk about the energy and water, but we as a team, we're trying to incorporate some of these smaller aspects as well into the design and construction, which will translate obviously to a healthier indoor environment for the firefighters and a more durable and higher environmentally performing building in the long run.
Okay, well, thank you very much to both of you for your presentation.